Hello noobs, welcome to another video of Noob coding. In this 2-video series, we are going to code and run a script that plays whack-a-mole for us using the Matchtemplate function within the opencv module in Python. Note that I assume you already know some very basic Python. If you don't, watch our video about how to build a mouse tracking program. I will link it on the description. There, you will learn the most basic stuff. On this first video, we will focus on understanding Matchtemplate, and on the next video, we will create a bot to play the game for us. The first thing we need to know is that opencv is a module that focuses on computer vision. So basically, it reads images we feed into it, and we can do all kinds of crazy stuff with the information we get back. The Matchtemplate function within the opencv module takes a small image called template and finds it within a bigger image called image in fractions of a second. Specifically, what it does is that it runs the template over the image pixel by pixel and assigns it a score depending on how much they look alike. Remember that a computer does not see like we do, so maybe something that looks completely different to us can look very similar in the eyes of a computer. You can read the official documentation to understand in more detail how it works. I will leave a link to it on the description. Let's begin. First, we need a bigger image to process. I will use this new Super Mario Bros. 2 cover image. I will link it on the description. Now, we need to get a template from it, which is what we will look for. In this case, we're going to look for this coin. I cropped it using Paint, but you can use whatever you want. I named it as template. Note that they are JPG format, but both PNG or JPG work fine for what we want to do. Now I will create a folder and call it Wackabot and put both images in there. I will leave my folder here in downloads. You can put your folder wherever you want, and also the images, you can name them whatever you want. That is something important to be noted. Time to open our code editor, which for me will be Visual Studio Code. Make sure the Explore menu is open. If it's not, you just have to click on this like 2 pages papers icon. So click on it, and this blue tab will appear. Click on it, and all we have to do now is find our folder, which is this one called Wackabot. I will highlight it and then click here on Add. As you can see, if I click on the folder name, it will display both images that, well, we had in there, right? So I'm gonna hover over here, and this new file icon will appear. When we click it, we will be asked to type a name. So this will be the name of our script, and I am going to call it mt_tutorial, which is basically a Matchtemplate tutorial .py. So I just hit enter, and this new tab opened, so we can write code here. It's very important that we finish the name of our file with .py. This way, the script or the file will be recognized as a Python document. Now, let's open a new terminal by clicking on this tab here, New Terminal, and down here the terminal should open automatically if you're using Visual Studio Code. And let's pip install opencv by typing pip install opencv-python and hit enter. Since I already have it installed, the requirement already satisfied message appears for me. But for you, well, it should install the module. Now let's go back to our script, and I am going to import the opencv module by typing import cv2. I am going to go to File and Save, and then I am going to run the code. For me, it is running and done messages appear. It means that well, the code ran successfully. There were no problems. Something important to be noted is that if you're using Visual Studio Code, this run button doesn't automatically appear for you when you install the Visual Studio Code. You have to go to Extensions, and then you have to look for Code Runner and install it. Now, let's create two variables that will contain the image and the template. First, let's create a variable called image and set it equal to cv2.imRead, and within the parentheses I am going to write image.jpg. What is happening here is that we are calling the opencv module by typing cv2, and from it we are calling the imRead function, which is basically image read. It will open the image and allow us to do stuff with it. Inside the parentheses, as you can see here, we used a string which is surrounded by single or double quotation marks to type the path to the image that we are looking for. Since the image is in the same folder as our script, we can just type the name of the image. However, if it were on a different folder, we will need to type the absolute path to it. To find the absolute path, you can just click on the address bar and copy, paste this, but just remember to add the name of the image. We can also create a new folder. I'm gonna call it imgs, and we can put both images in there. If I do this, the images and the script are no longer in the same folder, but it's in a subfolder. So what we can do is that I can just add the name of the folder, imgs / and the name of the image. Let's do this exact same thing with our template image. So I'm just going to copy this code, paste it here, and I am going to highlight image. In most code editors, when you press Ctrl+D, it's going to highlight the next occurrence of the word. So I can just edit both words at the same time. So I'm just gonna type template, and as you can see, it edited both words. So that's done. To check that we actually got the images, let's visualize them. To do this, let's call cv2.imShow. The first argument is a string. Remember that a string is surrounded by single or double quotation marks. And we're going to type in the name of our window. I'm just going to call it img. It can be any name that you want. It's just the name of the window. The second argument will be the variable containing our image, the image that we want to display. In this case, well, we want to display the image. Let's do the same for the template. So cv2.imShow parentheses, and I'm just gonna call this second one temp, comma, and now the image that I want to show is the template. If I run the code like this, the image will show up and disappear. So let me show you. Remember that before you run your code, you need to save the changes that you have done. So I'm just gonna press Ctrl+C to save, and I'm gonna run it like this. So you may have seen like the square, the window appear and disappear almost automatically. To keep the window running so we can actually see something, let's now run cv2.waitKey. If we put no arguments in the parentheses, the window will close when we hit the X button in it. We can now also specify how many milliseconds we want the window to run by typing an integer. So if I want it to run for 10 seconds, I can put 10 in there. If I want to run for 100 milliseconds, we'll just type 100 in there. But we want it to run until we decide to close it, so I will leave it blank. If we run the code, as you can see, both windows stay up, and well, the client window is too small, I can't seem to move it around, but you get the idea. We have both images in here, and well, we can see them, so we can be sure that the script has them correctly. Matchtemplate seems to work better on gray images, although this is not always true. However, I feel it will be better in this case to gray them. To convert the color images to grayscale, let's create an image underscore gray variable and set it equal to cv2.cvtcolor. The first argument in this function is the image we want to convert to grayscale. In this case, let's use our image, comma. The next argument is what type of conversion we want. So let's do cv2.color underscore RGB2 gray. Notice that those letters are capitalized in here, and this is very important because all of this is case sensitive. So what this means is, well, this function, what it does is that it converts an image to different types of colors, right? In here we wanted to convert an RGB image, which is a colored image, to a grayscale image. Let's do this same thing with our template. Now let's visualize them and make sure they are great. So I'm just going to recycle this code right here. And as you can see, the images are now great. Something to note is that these images are not actually stored in your computer. You can store them if you want, but well, it's not what we want to do. They will just show and be there while the code runs, and after that they'll be gone forever. Not the original image, but what you do to those images. Now let's create a variable called result. This variable will contain the result of running Matchtemplate. Let's set it equal to cv2.matchtemplate parentheses. Now the first argument for this function is the image, and as you remember, we have it stored in a variable called gray, well, image gray. So let's type it in there. The second variable, the second argument, is the template image, which is template gray. Something to note here is that both the template and the image must have the same, well, channels. They must be like the same colors. So if our template is grayscale and our image is RGB or colored, we're gonna have like an error. So that's something important to remember. The third and last argument for us is the method to use to perform the image comparison. There are several methods. If we go to the official documentation, those methods will be explained in detail. Even these crazy formulas up here. Though honestly, I have no idea of what they mean or how to read them. I scanned through them and I saw that some of them are, well, very, very similar, but still I don't know why they're different. The method that has always worked best for me is this one. You can also test out the different methods and see which one works best for you. So I just copied it, and to access it we need to type cv2 dot and the method that we want to use. And let's display the result. I'm actually going to display the color image and the result so we can compare them. Remember to save before running your code. And well, we have these two images now. This one is the original colored image, and this one is the result after running Matchtemplate. Now, as you can see, in here we have these small white areas, and those are the areas where there was a high match. And from we can see, it matched most of the coins. The coins that are shown partially were not matched. We'll talk about that later. If we use one of these methods, the SQDIFF, or this one that just says normed after it, it's going to work the opposite with the highlighting. So let me show you. I'm just gonna copy and paste it here in the method. Save and run. And now, as you can see, the black areas show the high matches, while the white areas show where there was, well, a bad score, where there was no match with the template and the image. So you might be wondering why only a small dot of black and white is matched or shown as a match instead of the whole template image within the image, right? And that's because only the top left part of the template is always going to be matched. So we can assume that over here it's matched, over here it's matched, over here it's matched, and so on. To visualize the result better, let's draw a rectangle over the best match in the original colored image. When we run the Matchtemplate function, a lot of information is thrown back at us, and in our case, stored in the result variable. Note that you can name your variables whatever you want. The information we can retrieve is the min value, max value, min location, and the max location. To access this information, we have to access the min max loc function. As an argument for this function, we're going to type in the variable containing the information that Matchtemplate throws back. So we're going to type the result variable in there. So what's happening is this. We run Matchtemplate and we stored the results in the result variable. And then we're using the min max loc function to sort the information that it's feeding us. And since it's gonna give us, well, since min max loc is going to sort 4 pieces of information back, we're using 4 different variables to store each piece of information. The min value is the minimum value gotten after comparing the images. The max value is the maximum value gotten after comparing the images. The minimum location are the coordinates of where the minimum value was found, and the maximum location are the coordinates of where the maximum value was found. Since we're running the method tmccoeff normed, we're actually looking for the maximum value, which is the highest match, and the maximum location, which are the coordinates of where that match was found. On the other hand, if we were running the SQDIFF or its normed method, we will be needing the opposite. We will be needing the minimum value and the minimum location, because for those methods, that's the best result. However, that is not the case, and we want the maximum values. In order to draw our rectangle, We just need two pieces of information: the top left corner of the rectangle and its bottom right corner. The top left corner is where we have our best match. So we can set it equal to the max location. Remember that Matchtemplate will always return the top left coordinates of the best match it could find. If we print the top left variable and then we run, we save our changes and then we run our code, you will see that we get a tuple with the coordinates of where the image had the best match. We can manually check this. If I open the image in Paint, the coordinates appear at the bottom part of the window, right about here. If I look for the coordinates manually, which is going to be right about here, it's about there. You will see that I end up on the top left corner of this coin right here, which is a perfect match. Now all we need to do is find the bottom right corner, which is right about here, and OpenCV will draw a rectangle for us using those references. To find the bottom right corner in a more dynamic way than just looking at the image ourselves, we can just add the temple's width and then the temple's height to the coordinates. To do this, we need to import the Numpy module. So underneath the importing of the opencv module, we're going to type import numpy, and so that we don't have to write numpy every time we want to call the module, we can type in as np. This way we're going to call the numpy module as np. We don't have to pip install numpy, because when we pip installed opencv, since opencv makes use of numpy, it also installs with opencv. Under the grade images, let's get the template's dimensions. Let's create two variables, temp height and temp width, which they stand for the template's height and the template's width. In order to access those dimensions, or to get those dimensions, we're going to access the np module, and it has a function called shape. The argument for this function is where, or the image that we want to get the dimensions from, right? So we're going to get them from template grade. So as you can see, running this function will give me two values, and for that reason I can create two variables. Each one will contain each value. If we run this function on the template image, or the template variable, which is colored, it's going to give me three values, the third one being the channels. That doesn't really matter right now, so let's just use the function on the grade image and everything will be fine. So the height is the top to bottom size of the image, and the width is the side to side size of the image. So right now I'm just gonna print both values so we can see what happens. So temp height and temp width. Save and run. So as you can see, we get the template's dimensions down here. With this information, we can now get the coordinates of where the bottom right side of the rectangle will be. So to get them, let's create a bottom right variable and set it equal to a tuple. Remember that a tuple is surrounded by parentheses. So to make this tuple easier to read, I'm just going to press enter and do it line by line. So the first thing we need to do is get the bottom x, the bottom right x. To get it, we just have to add two values. The first value is the top left x, which is 152. So as you may remember, the top left variable contains the coordinates of the best match, right? So it has the x and the y side. To access the first element, which will be 152, we need to use square brackets, and in the square brackets, the first index is actually 0. So by typing top left square brackets 0, we're accessing the first element. This may seem weird, but when programming, you start counting with 0, not with 1. So this accesses the first index. And to this, we just need to add the template's width. Now, to get the bottom right y, we need to access the top left variable, which contains the tuple with the coordinates, and the second element will be index number 1, right? And to this, we just need to add the temple's height, and that will do it. Also, don't forget that when writing a tuple or a list, each element must be separated with a comma. Now that we have the top left and bottom right of the rectangle that we want to draw, all we need to do is draw the rectangle. To do this, we're going to call the opencv module, and it has a rectangle function. The first argument in this function is where we want to draw the rectangle, and we want to draw it on the colored image, so we're going to type image in there. The next argument is part 1, which is the top left coordinate, and we're going to set it equal to top left. The third argument is the bottom right coordinates of the rectangle, so we're going to do bottom right. The next argument is the color. Now, for this, we need to specify a tuple with RGB code of the color. As you may know, RGB stands for red, green, and blue. So the max is 255 and the minimum is 0. So if we wanted to put in the red color, we can do 255, 0, 0. This will mean that I want max red and 0 green, 0 blue, RGB. On the other hand, if I wanted green, I will need to type R0 for green 255 and for blue 0, and so on. If I wanted the rectangle black, I will need to put the minimum on the RGB, which will be 0, 0, 0. And if I wanted white, it will have to be 255 on all three elements. So different combinations from 0 to 255 in, well, those RGB numbers bring about different colors. So let's just type, I don't know, 58, 200, and 63. Let's see what color that gives us. The final argument for this function will be the thickness of the line. So let's just do 3. There are more arguments that we can specify, but this is good for now. Let's display the result by running imshow on the original image now. So this should do actually. So I'm gonna save and then let's run. So as you can see, there's a green rectangle here, and that means this is the best match. As you may have noticed, when we run Matchtemplate, we can see in the result that a lot of the coins were matched. However, the rectangle was drawn over only one coin, which is considered the best match. So what we're going to try to do now is that we're going to try and draw a rectangle over all of these good matches. Before we can get into that, we need to understand a little bit more about how the scoring process works. So as I have explained before, what Matchtemplate does is that it takes the template image and runs it pixel by pixel over the image. And each time it does that, it assigns a score depending on how much the template looks like the area of the image that it's scanning through, right? So if the template is over here, it might give it a score of, I don't know, 25%. And when it reaches a coin, it might give it a score of 90, 95, 99, 85, or something like that. If it goes over the Koopa over here, it may give it a score of, I don't know, maybe 5% or so. So I understand that each method works different. However, the method that we are using, CCOEFF normed, assigns a score between 0 and 1. So just to make sure, let's print the result. So as you may remember, well, let me delete all the print statements so we find the result faster. So if I run print and I print the max value, we can see that we get at 0.99. So that means that the best match has a 99% chance of being the image, right? Now that we know this, we can actually set a threshold. So I'm gonna set it down here. So I'm gonna create a variable called threshold and set it equal to 0.85. So the idea is this. The idea is that if we find a match that has an 85% resemblance, we're going to consider it to be a good match. We're going to consider it to be a coin. Now let's create an array with all the results that meet our criteria. So I think an array is a bit difficult to explain, but for now think of it like a list. It has many elements in it that we can access. To create this array, let's create a variable called locations, and we're going to set it equal to np.non0 parentheses. In the parentheses, we will type our criteria, and we want to store all the matches in the result that are greater or equal to the threshold. So again, this line of code will create an array called locations with all the matches where there was a score of 85% or higher. Finally, let's create a for loop. We want all the top left coordinates of the matches found in zip This one is a bit hard to explain. I don't fully understand all the backend process going on, but basically we are creating tuples of all the top left coordinates, and then we are going to iterate through each top left coordinate in order to draw the rectangle. So to actually draw the rectangle, let's go cv2.rectangle parentheses. Note that I am typing this line of code with a little more indentation than to where the for loop was typed. This is necessary because we are telling the script that we will iterate through drawing the rectangle several times until we draw over all the coins found. If I type it with the same indentation as the for loop, there will be an error because the for loop will be empty. To make the parameters of the rectangle function a bit more clear, I will type one parameter per line. So I'm gonna hit enter. And remember, the first parameter is image. Something else we can do to make it even more clear and easy to read is that if I hover my mouse over the function, it shows me what the parameters are. Then I can type the name of the parameter, which is img for image, and then I can set it equal to the variable that I am going to use for the image, which is image. Remember to separate each parameter with a comma. Enter. The next parameter is part 1, and we're gonna set it equal to top left, comma. The next parameter is the complex one, which is part 2, equal to a parenthesis. To get part 2, which is basically the bottom right part of the rectangle, we need to access the top left in its index 0, which is the first element, which is equal to the x coordinate. Here we just add the template width, and this should be equal to the bottom right x. Now we're gonna access the top left index 1, which is the second element, which is equal to the y coordinate, and we're just going to add the template's height. This should be equal to the bottom y. So again, part 2 is a tuple. So a tuple that is going to contain two pieces of information. The bottom right x, which we get by adding the top left x and the template's width. And also we need the bottom right y, which we get by adding the top left y plus the template's height, comma, and the next parameter is the color of the rectangle. So as you can remember, we're gonna set it equal to a tuple, and we have to add an RGB value for a color. So again, let's just do a random color. Let's do, I don't know, 89, and then 68, and then 59. Let's see what color that gives us, comma, and we're gonna set the final parameter, which is thickness, and we're gonna set it equal to, let's do 1 this time, and let's see how that looks like. Something that you might have noticed is that we are assigning a new value to the top left, and that we are now creating our bottom right coordinates right here. So this means we can just delete what we previously had. We can also just leave it there. So what's gonna happen if we leave it there is that the script is going to assign these values at first, but when it gets over here, it's going to assign its new values, overriding the previous ones. But to save like fractions of a second in speed, let's just delete that. Now an error is thrown, and the reason that's happening is because I have this function, this extra rectangle function. So as you may remember, we used this statement to draw the rectangle over the best match. Since we're now drawing the rectangle over all the matches that meet our 85% criteria, we no longer need this statement either. So let's delete it. And again, what's gonna happen here is that the for loop is going to access all of the best matches that we have, and it's going to draw a rectangle over all of them. At last we hit enter, and after the rectangle statement, the rectangle function, we can return our indentation to normal by pressing the delete key. This will tell our script that the for loop is over, and that when it is over, it's going to continue down here. Now what we want to do after all the rectangles are drawn is, well, show the images, right? So since I already have the image show function on the image, this will do. So I'm just gonna save, and then let's run the code. And now, as you can see, a rectangle has been drawn over all of the coins that are a full image of the coin. Matchtemplate was unable to recognize these coins that only show half of the coin. So now that we understand how Matchtemplate works and how to use it, it's important to know that it is only good to find perfect matches. So it was unable to find these coins that only show half because they're not a perfect match, right? Half of the coin is missing. So it's very hard for a Matchtemplate to find images like this. And also, if the template is a different size, if it's a different color, if it's rotated or such, it will have a hard time finding it in the image. So for example, these coins right here, well, we as humans can see that they are coins. However, these 3 coins that Luigi is carrying down here are at a different angle. And this one is kind of a full coin, but it's rotated, like it's sideways, and these ones are like vertical. So the weakness and the strength of Matchtemplate, depending on what you are doing and on what you need, is that it's going to work better with perfect matches. That's all for now. Tune in for our next video in which we will automate a whack-a-mole game using Matchtemplate. Don't forget to like and subscribe, and see ya!